Hello YouTube. This is about genetic algorithm in which we actually initialize a population with some random values. We will calculate the fitness of the function different populations. Then we will select two populations based on their fitness values, and we will cross over them to reproduce a new population. And based on some percentage we will introduce some mutations in it and terminate the criteria if we like, or we can just create another loop of by creating 100 different population and starting it again and again and so on, and we can end it wherever we like. So this is the program which I'm talking about for genetic algorithm. Uh, okay, in which we will try to create some sentence based on genetic algorithm. We will give the target and we will try to create it using some genetic algorithm. This is we are actually using a lot of programming patterns like implement interfaces, how they interact with each other, some polymorphism, some OOPS concept. So it will be better if you are familiar with this one, like override and implementation of interface, how it works, casting of classes and all. So here we go. So at first we'll create a genetic algorithm with three functions. First, fitness, then reproduce. We will pass the same object, and with the object that called this function will cross over with that object and create a new child and return it. Then in that child will actually use again this function mutate with some mutation rate that we will pass from 0 to 100%, and it will change some of its properties. Okay, this is the class I'm talking about, for sentence, which will implement that interface and all its functions. So at first we'll give it a target and a gene pool where each can have all the characters from A to Z including a space. Okay, and we have to actually created this sentence as target. Okay, this is the individual which we will be comparing. At first we will create a random string of that length equal to the target length. Okay, then we will implement the fitness function based on how much different it is. We'll give it some values and we will do the power of 2 raised to power of that temp variable, how many of them are equal. Okay, so it will give us some kind of values. Then this reproduce part where we take the another parent and the current parent and cross over them, like based on some random choice we can either take any first character of either first parent or second parent and so on till the target length and return it. Then the mutate, based on some mutation rate that we have passed, we will modify the gene of the gene, you can say, which means any of the characters of this string. Okay, or we can just assign it whatever its character already was based on that, if mutation rate is satisfies this condition, like whatever our random generation random number is in double is less than or equal to this mutation rate. So this is the apply GA class which will actually apply all the genetic algorithm functions on an entire population. You can see we are actually using arrays to store all the populations and their fitness, probability and cumulative probability. Okay, and these are the parameters. So at first we will initialize all the population. Okay, and at first we don't want any mutation if we have not passed mutation. Okay, we will calculate the probability based on the fitness. Okay, here we are only calculating the fitness values. Okay, based on we saw in this for sentence that if the characters matches then we will increase this, and do the math of 2 raised to power 10. Then this is the pop probability, where we will actually calculate the sum of total fitness and apply the probability of a particular fitness. It will actually help us to select from the pool of population which of them is better suited, like which have the more probability. And for that we are actually using cumulative probability. Okay, there are different ways you can search, but this one is actually simpler. Once we will actually take a cumulative probability of all the populations, you can see that it will start from actually 0 to 100. Okay, for first to the last one, but still in between there will be some gaps like 0, 1, um, 20, 100. So something that has 80% probability will lie between this 20 and 100, and something with probability of 0 to 1% will lie between this, and we will actually use some kind of random choice to get a number and use that to get a parent. So this is the new generation creator. First we find the population fitness, then population probability, and then cumulative probability. Okay, create a new what do we say, yeah, create a new variable. Okay, then for the entire population we'll go through these things: random select two parents, and then reproduce and mutate this using the mutation rate as the parameter. So random select, you can see we are actually taking next double, which will generate anything between 0 to 1. Okay, and that probability will actually use as, if that selection is just less than cumulative probability, okay, it will select that population and that individual of that population and return it as the parent 1 or 2. Okay, so this is the class which is the main driver class, which will use all the previous explained classes to show this genetic algorithm for this example. Okay, first we initialize the population, give it some values. Okay, then for we are running this simulation for 3000 generations. Okay, and our population size is only 100, and we are using actually 0.02 as the parameter for mutation rate. Okay, after new generation we get that values, and we will print the first element of each generation, which can be any one of them, any which can have any of the values. Okay, see if any of them is actually directly equal to the target, we will just return, otherwise we will keep printing it. So let's run it. Okay, so at first here you see that I have printed all the individual strings. So you can see at first it has the same length as it should have the same length as target, but there are many of them is, and all of them are actually just some gibberish, and these are just first element for second generation, third generation, and so on. And slowly you will see that it started to match with this target that we have created this sentence. Still, genetic algorithm is totally based on random, so you cannot exactly hope that it will have the same value that as we want as a target. Okay, you see at the end we have something like this. It is not exactly what we wanted, but it is actually close, and it is just based on some random selection from the entire population and crossover and some mutation. And also let me show you some example of how this actually affects the population, the number of generations and all. Okay, let me just not change the population, let me only change the generation. We are only going for 300 generations. Okay, yeah, something like that. So I think 3000 does not even make sense to have that much generation, but having more gene, will actually make you, more population will actually get your chances to have closer to the target. Let's just increase it one more, 0. Yeah, it will be slow, it will be slow. Okay, I'm not even sure what happened. Okay, but okay, let's go back. 2000. Yeah. Okay, now change, let's change some parameter of population. Let's just make it as 20%. Yeah, you see, so many mutation we have. We had almost sentence word, but still it changed into something Chewbacca. Okay, if you increase the mutation rate to 90%, it will again become gibberish. See, so it's rather beneficial to keep it as close to 0. Okay, something like this should be fine as well. Okay, it did not work. Let's just keep it more small. uh, I think we should increase the generation. Okay, so you see, this is how everything changes based on mutation rate, population, or number of generations you run this simulation for. That's all. Thank you.